Today we are going to find out the change of gravitational force with the change of mass and change of gravitational force with the change of distance. How the increase or decrease of mass affects the gravitation force and how the increase and decrease of distance affects the gravitational force between two bodies. And actually this part is related to the numerical problem, and so I want to start with how to deal with the power of 10, and then only we'll be able to solve the numerical problem. Okay, let's start with this, how to deal with power of 10. Look at this, how to write very big number in power of 10. This is very big number, and this big number cannot be written in the numerical problem while solving the numerical problem related to gravitation. Now what we do for this, decimal point is at this place and we'll put the decimal point after one digit. It means behind 2. Then how many digit it is shifted to left hand side? 1, 2, 3, 4, 5, 6, 7, 8 digit left hand side. If a point is shifted to 8 digit left hand side, then we can write 2.3584328 into 10 to the power 8. If we shift 8 digit left hand side, then we have to multiply the number with 10 to the power 8. It means 1 having 8 0. Then only this number, the second expression, will be equal to first expression. Till now we have many digits and we are not writing this digit, all the digit. Normally we will take just 2 digit after decimal point. Here we have 3 and 5, 2 digit, and if third digit is 5 or more than 5, then we'll take 1 as carry over to second digit and we'll write 2.36 and into 10 to the power 8. This way a big number can be written shortly in terms of power of 10 this way, and this is approximately equal to this number. Okay, now how to write very small number in power of 10. Let's say this is very small number. After decimal point there are so many 0 and then 667 comes. This is the value of gravitational constant. And this very small number, how can we write in power of 10? We can write this way. Point has to be shifted to this place, means after one digit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digit. When point is shifted to 11 digit right hand side, then we can write 10 to the power minus 11. If it was shifted to left hand side, we have to write 10 to the power how many digit it is shifted. This is just the understanding about the expression of very big number and very small number in terms of power of 10. Let's use this knowledge. Two objects are at a distance of 400 meters and the gravitational force between them is 4.16875 into 10 to the power 4 Newton. If mass of one of them is 2 into 10 to the power 7 kg, calculate the mass of another. This is the question. Looking at the question, sometimes we will be confused and we feel that the numerical problem is tough. It's not like this. When we write the information given in the numerical problem, then we feel the same numerical problem very easy. Look at this, distance is given 400 meter and gravitation between those two bodies is given 4.16875 into 10 to the power 4 Newton. And another information is also there, mass of first body m1. There are two masses certainly, and one is represented by m1 and another we have to calculate. M1 is 2 into 10 to the power 7 kg. Mass of second body M2 is the question. Now how can we solve this? One point is missing. Here gravitational constant is not given, that's why gravitational constant we have to take ourselves 6.67 into 10 to the power minus 11 Newton meter square by kg square. Now we can use the formula F equal to G m1 m2 by d square. Now we are writing the value of each of the physical quantity. F is 4.16875 into 10 to the power 4. It is given here, and G is 6.67 into 10 to the power minus 11. We know this, and M1 is 2 into 10 to the power 7. M2 we are going to calculate. Here D square is given, that's why 400 is square. I am not writing units in the process. It is not necessary to write units in the process. We will write unit in the given and in the answer, but in the process it is not necessary. Now next step, if 400 square is taken to left hand side, we have 400 square here, and 6.67 into 2 gives 13.34. 10 to the power minus 11 and 10 to the power 7 is here. That's why same base power can be added or subtracted. Minus 11 plus 7 gives 10 to the power minus 4. M2 we are going to find out. Now next step, M2 is equal to, if we take all this number 13.34 into 10 power 4 towards left hand side, then we'll have 13.34 into 10 power minus 4, and M2 is equal to this. Now we have to divide this with this number, and so when we divide we will get 0.3125 into 10 to the power 4 is in numerator, in denominator 10 to the power minus 4. When it is taken to numerator it becomes plus 4. That's why 10 to the power 4 into 10 to the power 4, and 400 square is 1,60,000. Okay, now let's go to next step. M2 is equal to, and if 10 to the power 4 into 10 to the power 4 is here, then we have same base power can be added, 10 to the power 8, and 1,60,000 is can be written this way, 1.6 10 to the power 5, because point is here, it is taken to 5 digit left hand side, and that's why I'm converting it into power of 10. This we know. And after this, what is left? 1.6 multiplied by 0.3125 gives 0.5, and 10 to the power 8 into 10 to the power 5, and same base power can be added or subtracted, but here we have point number, we have to shift it to one digit right hand side, and if it is shifted to one digit right hand side, it should be multiplied with 10 to the power minus 1, because point is shifted one digit right hand side, into 10 to the power 8 into 10 to the power 5. We have power of tens, we can subtract and add them with each other. M2 is equal to 5 into 10 to the power minus 1 plus 8 plus 5, it gives what? 5 into 10 to the power 12. Therefore we can say that mass of second object is 5 into 10 to the power 12 kg. This way we can solve the numerical problem, and we are using our concept of power of 10. Now we are going to focus on the effect of change of mass on gravitation and effect of change of distance on gravitation. What will be the change in the gravitational force between two bodies when one of the mass is doubled? We can understand this way. Let's say two bodies have mass m1 and m2, they are separated by a distance d. Then we can say let mass of two bodies are m1 and m2 separated by the distance d. Now according to the law of gravitation, F equal to g m1 m2 by d square. We know this. This is equation number 1. But here one of the mass is doubled. Let's say m1 is doubled. Then we can say that this m1 is doubled, so it is no more m1, it is 2m1, although remains same. In this case, new gravitational force will be capital G 2 times m1, because mass is doubled, m2 remains same and d remains same. If this 2 is taken first, then we'll have F nu equal to 2 times G m1 m2 by d square. This is equation number 2. G m1 m2 by d square is equal to F. It can be taken here also. F nu is equal to 2 times F. Instead of G m1 m2 by d square, we can write F. That's why comparing equation 1 and 2, we can say F nu equal to 2F. Okay, we can write this. New gravitational force between them is 2 times the old gravitational force. When the mass of two bodies are doubled, what will be its effect on the gravitational force between them? Now we are going to double both the masses. If we have two masses m1 and m2 separated by distance d, then let the mass of two bodies are m1 and m2 separated by the distance d. Then according to the law of gravitation, F equal to G m1 m2 by d square. This is equation number 1. If both the masses are doubled, then m1 is no more m1, it is 2m1, m2 also 2m2. Now F nu will be gravitational force, new gravitational force will be capital G 2m1 2m2 by d square. Now 2 multiplied by 2 becomes 4, 4 times G m1 m2 by d square. This is, let's say, equation number 2. If we compare equation 1 and 2, then instead of G m1 m2 by d square here, we can write F it means F nu is 4 times F. So we can say, comparing equation 1 and 2, F nu equal to 4 times F. So we can conclude that new gravitational force is 4 times greater than the old gravitational force. This is the effect of increase of mass on the gravitational force. Let's talk about distance also. What will be the effect on the gravitational force between two bodies if the distance between them is doubled? Let's say M1 and M2 are two masses separated by a distance d. Then according to the law of gravitation, F equal to g m1 m2 by d square. This is same as in previous case. This is equation 1. When the distance between them is doubled, it means no more d, it is 2d. Then what happens? Now F nu equal to g m1 m2 by, instead of d we are writing 2d, and 2d square. This means what? 2 square is 4, d square remains same. 1 by 4 g m1 m2 by d square. This is our second equation. If we compare first and second, then in place of g m1 m2 by d square we can write F. That's why comparing equation 1 and 2, we can say F nu equal to 1 by 4 F. It means now gravitational force is decreased by 4 times. It is now quadrant. That's why new gravitational force is quadrant of the old gravitational force. When distance increases, gravitational force decreases. Now let's talk about another. What will be the change in the gravitational force between two bodies when the distance between them is half? We can write this way: m1 and m2 separated by distance d. Let mass of two bodies are m1 and m2 separated by the distance d. Now according to Newton's law of gravitation, it is same as previous. F equal to g m1 m2 by d square. This is taken as equation number 1. When the distance between them is half, now we are going to decrease the distance. Let's say it was previously d. Now we are going to reduce the distance by half, means half d, or d by 2. Then F nu will be g m1 m2 by, in place of d we are writing d by 2, and here it is d square, that's why d by 2 is square. Now 2 square 4, d square remains same, that's why F nu equal to 4 times g m1 m2 by d square. This is equation number 2. In place of g m1 m2 by d square we can write F. That's why comparing equation 1 and 2, we can say F nu equal to 4 times F. It means when distance is halved, then the gravitational force increases by 4 times. Therefore new gravitational force between them is 4 times the old gravitational force. What was our target set for today? When mass increases, what will be its effect on gravitational force? When distance increases or decreases, what will be its effect on gravitational force? We proved this mathematically, that gravitational force is directly proportional to mass but inversely proportional to the square of the distance between them. Okay, we'll meet in next class. Thank you.